warahmatullahi wabarakatuh. Good morning, everyone. Today, we live in an era where technology doesn't just change how we live, it changes how we experience stories. Movies are no longer just watched, they are chosen for us by intelligent systems that understand our taste better than we do. Our team was inspired by this transformation, and that's why we present to you our project, an artificial intelligence based movie recommendation system. This system is designed to make the process of choosing a movie effortless, personal, and meaningful, turning endless scrolling into instant satisfaction and many more. So, let's take a closer look at how we build a system that doesn't just recommend films but learn what you love to watch. Our members are consist of three peoples. First, me, Zakil Haidar, with the student ID 2024-32044, and
And I'm Nicoy Calafier with study number 2024-32048.
And I'm Jenny Agustin with student number 2024-32041.
the first slide will be presented by Jenny.
Okay, for the first slide, we will talk about the problem description about our system recommendation. And the problem basically is the development of digital technology has transformed to the way people enjoy movies, shifting from cinemas to streaming platforms such as maybe Netflix, YouTube, or etc. These platforms provide thousands of titles across various genres. But however, the vast number of choices often makes it difficult for users to decide what to watch according to their preference. To address this issue, an AI-based recommendation system is needed, one that can tailor movie suggestion to users' interests and viewing habits based on their watch history, ratings, and preferred genres. And this study and the study examination methods for developing a movie recommendation system capable of providing personality relevant recommendations, thereby reducing search time and increasing user satisfaction. Okay, and the next slide we will talk about the purpose and benefits of this system recommendation film based on AI. For the purpose, for the first one is develop an AI-based movie recommendation system that analyze user preference and behavior. Apply the content-based filtering method to recommend movies with similar content, providing recommendation accuracy using TFD, IDF, and cosine similarity. Optimize user experience by providing fast and relevant recommendations. And the last one, enhance user satisfaction and retention on the streaming platform. And also the benefits, we have three benefits. For the first one is for users, and for streaming platforms, and for the film industry.
Now let's discuss about the data types and sources we utilize for our projects. Understanding our data is the fundamental steps of our projects. The primary data we are working with is a film data that is uh, that is that is the data type is structured, which as you can see is structured data. Structured data means it organized in a clear fixed format, making it easy to store, manage, and query. Specifically, we collected and processed several key attributes for each film, that is movie title, genre, release year, director, main cast, synopsis, rating, text, or keyword. This structured format allows our algorithm to easily process and compare films and user preference, which is crucial for building an effective recommendation system. But what is structured data? Well, structured data is a data that highly organized information that conforms in a fixed schema, typically residing in tables with rows and columns, making it easy to search, query, and analyze using conventional tools like SQL or for example, data from a relational database. Conversely, unstructured data lacks a predefined format or an organizational model and is stored in its native state, such as text, document, image, videos, and social media posts. That is the difference between structured and unstructured data. Next, we move to the chosen method. The first chosen method is clustering. The clustering method that we choose is K-means clustering. K-means clustering is the one of the most widely used methods in the field of unsupervised learning. The main objective of this algorithm is to minimize the distance of each data point to its cluster center, or we call it the centroid, which represent the average positions of all data within that group. The algorithm tries to minimize the distance between each data points and its centroids, ensuring that the items within the same cluster are as similar as possible, while the chosen one, those in the different cluster, are more distinct. In the context of our AI-based film recommendation system, K-means plays a crucial role in organizing users or movies into meaningful groups. The K-means algorithm works iteratively. It starts by randomly selecting a number of cluster centers or centroids. Then, algorithm assign each data point to the closest centroids using a distance calculation known as the Euclidean distance, expressed as the distance between a data point x sub I and a centroid c sub g is equal to the square root of the sum of the square differences between each feature of the data points and the corresponding feature of the centroids from n equals to 1 to n. Overall, key-means clustering is an effective technique for identifying patterns and grouping similar users or movie. It enhances the recommendation processing by allowing the system to focus on smaller, more homogeneous groups, resulting in faster computation and more accurate. Next, we move to the selected method, the final recommendation. The chosen approach is the hybrid approach, which is the uh, collaboration of collaborative filtering, or CF, and content-based filtering. The collaborative filtering approaches focuses on identifying patterns of similarity between users. The basic principle is that two users share similar preferences for a number of movies. They are like to enjoy other similar films as well. And the content-based filtering, or CBF, approach is used to analyze the characteristic of each movie. And how we could get the final score? We could use we could use to calculate that R sub final of user U and item I equals alpha times R sub CF of user U and item I plus the beta times of R sub CBF of user U and I.
Okay. In this slide, the process began with the input data stage. Here, the system collects user and movie data, such as watch history, user rating, favorite genres, as well as movie details like title, actor, director, and release year. This data become the foundation of the entire recommendation process. The better the data quality, the more accurate the recommendation will be. Next, uh, in the clustering step, in this step, the system group movies into cluster using algorithm like key means. The purpose of clustering is to organize similar movie together, making the recommendation search process more efficient. After that, we have the movie database page. All clustered data is stored in the database, which serves as the main source of information for the recommendation system. This database is updated when new movie of use data are added. Then come the algorithm process, the core of the AI system. Here, machine learning algorithm analyze the relationship between user preference and movie feature. For example, the system use content-based method to calculate similarity between movie based on their genres or description. The next stage in genre score, the system calculates a similarity score between the user and its movie. The high the score, the movie stable, the movie is for the user. The score are the user to rank and decide which movie should be recommended first. After that, we move it to the visualization interface. At the point, the system convert the AI result into visual that are easy to understand, such as movie list, poster, or interactive display. This test appeal to concept human-computer interaction to make the interface user-friendly and attractive. Next, the system process display interface test. Here, the recommendation are shown to the user who can read movie description. They directly watch the suggest films. The output is adaptive and server as feedback to improving the next recommendation. Then come the another recommendation stage. The user is asked whether they want more recommendation. If the user say yes, the system will process new database based on update preference. If not, the process stops. This shows that the system is dynamic and learn from use behavior. Finally, we reach the end process. At this point, the recommendation session finishes after displaying the final result or when the user decides to stop. In summary, this all-based recommendation system combines multiple technique like collaboration filtering, content-based filtering, and clustering to deliver accurate, personalized, and efficient movie recommendation. It helps use find what the love faster and is their overall streaming experience.
Now we move to potential biases and errors in AI-based movie recommendation systems that we built. There are at least 5 potential biases that we detected. That is, dataset imbalance, overfitting, noise, sampling and representational bias, and confirmation bias. What is dataset imbalance? When training data is dominated by popular films, the model learned bias patterns, favoring mainstream genres while neglecting local or independent films. Overfitting. The model memorizes training data instead of generalizing, making recommendations accurate for existing users but poor for new ones. Cold start problem. Noise. Noise is inconsistent input, fake reviews, or spam ratings distort data quality, leading to irrelevant or illogical recommendations that will reducing user trust. Sampling and representational bias using unrepresentative data, for example, from one region, limits cultural diversity, making recommendations less inclusive and biased toward Western content. And the last one is confirmation bias. The system reinforces users' existing preferences, creating a filter bubble that limits exposure to new or diverse movie genres. In conclusion, an AI-based movie recommendation system helps users discover films that match their interests and viewing habits without the need for manual searchings. A hybrid approach that combines collaborative filtering, content-based filtering, and clustering key means makes the recommendation more accurate, personalized, and efficient. This system will help overcome information overload on streaming platforms while increasing user satisfaction and loyalty. With further development, such as context integration, richer data, and explainable AI or XAI for transparency, the system has the potential to become an innovative solution in the digital entertainment industry. Well, that's all from us. Um, And that brings us to the end of our presentation. Through this AI-based recommendation system, we've shown how technology can bring can bridge the gap between choice overload and personal experiences by combining collaborative filtering, content-based filtering, and clustering key means. The system learns, adapts, and evolves just like human preferences. We believe that the future of entertainment is not just about having one, not just having more movies, but about finding the right movies at the right time for the right person. Thank you for your attention, and we hope our work has inspired new ways to connect people, data, and stories. Wassalamualaikum warahmatullahi wabarakatuh.